Pneumatic and hydraulic control systems utilize valves, and there are two general categories of valves: finite position valves, which are either off or on, and infinite position valves, which change the flow rate of the fluid. In this video, we will only be discussing finite position valves. Directional control valves are examples of finite position valves, and they are used to direct the flow of fluid in the system. One common directional control valve is a spool valve, and so here's an example. This valve has 3 ports. One is connected to air supply, one is vented to the atmosphere, and one port is considered the output port. So 3 ports, and then there are 2 positions for this valve. In this position, port 1 is connected to port 2, so our output is connected to the supply. And in the other position for the valve, the output is vented to the atmosphere, so port 2 is connected to port 3. So this is an example of a 3-port, 2-position valve. So in this case, air would flow from 1 to 2, and in this position, air would flow from 2 to 3. So the direction of the flow is changed. And there are different ways of actuating these valves to switch them from positions. They can be mechanically actuated, electrically with solenoids, or you can use pneumatic pressure to switch the positions, and we'll cover that later. Another directional control valve is the Poppet valve, and so this valve flow is either off or on. Poppet valves use a ball or a cone against a valve seat to shut off flow, and they're typically normally closed valves. So a spring seats the ball against the valve seat, and whenever the button is pressed, the valve is moved away from the seat, and port 1 is connected to port 2, and so the valve is fully open. This valve has 2 ports, the supply and output, and it has 2 positions. One position, the ports are closed off, and the other position, the ports are connected. So this idea of the number of ports and number of positions is important for valve classification. Whenever we're working with pneumatic diagrams, symbols are used to represent the valves instead of a mechanical drawing like this or this. And this slide shows the symbols for the actuation type. So this is the method by which the valve is switched from one position to the other. Here's the symbol for a push button, like in the Poppet valve of the previous slide. Plunger, lever, roller, these are all mechanical actuators. There's also a pedal, and here's the symbol for application of pneumatic pressure. So just like a button can push a valve from one position to the next, like shown here, you can use pneumatic pressure to push a valve from one position to the next. And then a spring actuation can switch a valve. So here's the symbol, and here it is in practice. And this would be a symbol for a solenoid, an electromechanical actuator. And here is the symbol for the valve. You can see the actuation type shown. We've got the push button on one side and the spring on the other. This is the symbol for the Poppet valve that was in the previous slide. So this symbol corresponds to a valve that looks like this. These symbols use a line with an arrow to indicate the direction of fluid flow. They use these T's to show that a port is closed off. And then there is a line showing where the port connection is. And so you see there are 2 ports on this valve. Just like here, there are 2 ports. And then the positions are indicated by these rectangles or boxes. So that valve had 2 positions, either fluid flowing or both ports closed off. And so this symbol has 2 boxes. In this position, the ports are closed off, and in this position, fluid flows from one to the other. So you can sort of think of the actuator pushing the symbol so that the symbols inside the rectangle or inside the box line up with the port. So here we have the return spring pushes the rectangles this way so that the valve is in this position so that the ports line up with these T's. And if you press the button, then the boxes would move this way so that the ports would line up with this arrow. And so that would look like this. So there's a drawing of what it would look like if the button was pressed. So you can compare the two. This symbol shows the valve in its nominal state. It's normally closed, so the spring is pushing the boxes over here this way to the left so that the closed symbols line up with the ports. And then if someone was to press the button, the boxes would move to the right, and then this line would be collinear with the ports. So we'd have 1 and 2. So those are the two positions that the valve could be in. I guess I should include, or I definitely should include the symbols for the other position. Okay. So this position indicates that the valve is open. It's being actuated by the button. And then this position over here is whenever the button's not pressed. Oh, and one other item. This is referred to as a 2-2 valve. 2 ports and 2 positions. So here's an example of a 3-2 valve. This has 3 ports. So the ports are only drawn in one of the, or connecting to one of the boxes. So 3 ports and 2 positions. There are 2 boxes. Let's go to the mechanical drawing for this valve. This is a spool valve again. And just like before, there are 2 positions and 3 ports. And so in this position, ports 1 and 2 are connected. So fluid flows from 1 to 2. And this is the normal position for the valve because the spring pushes the spool to the left. Now this valve has a solenoid actuator. You can see by this symbol and here on the drawing. And when that solenoid is energized, it pushes the spool to the right. And so in that case, this spool moves to the right, and so then the output port is connected to the exhaust port in that case. So this is mechanically what it looks like when it moves from one position to the next. And then the symbol, this is what the symbol would look like for this valve. So again, it's a 3-2 valve. There are 3 ports, and you can see on this box there are 3 ports shown. 2 positions. It can either be in this position or this position. And so there are 2 boxes in the valve drawing or diagram symbol. And the actuators are a solenoid and a spring. So solenoid and a spring. And now, if the solenoid were energized, then the symbol would look like just the ports would be connected to the position on the left. So this is the valve as it is. Anyway, regardless of the position, in this position on the left, or regardless of the state it's in, I should say, in the position on the left, fluid flows from this port to this port. Position on the right, fluid flows from this port to this port. And so if we energize the solenoid, then the ports would be connected as shown in the position on the left. So that would be 3. So you can just think of it as the boxes sliding to the left or the right depending on which actuator is pushing on the valve. So when the solenoid's not energized, the spring is pushing on the valve, so the boxes slide this way, and this box is in line with the ports. When the solenoid's energized, the boxes slide to the right, and then this box is in line with the ports. So you can see this directional control valve illustrated here. The direction of the flow goes this way in one position and this way in the other position. So here in the diagram it goes this way in one position and this way in the other position. A 4-2 valve. You should know how many ports and positions that has. 4-2, so it has 4 ports, and they're shown here, 1, 2, 3, 4, and 2 positions. So in this valve you can see that in neither of the positions is any of the ports closed off. And you can see the actuation type. Again, we have a solenoid and a spring. And here is an example diagram for a pneumatic system. So we have 2 valves. Both valves have 2 ports. So 1 port and 2 ports, 1 port, 2 ports, and 2 positions, the 2 boxes. And they're both actuated by a push button and a spring. So the question is, how would you label the push buttons in this pneumatic lift system? So we're using pneumatic pressure to extend the cylinder. So when this portion of the cylinder is vented, it's going to retract, and when it's given pressure, then it'll extend. So here's our supply pressure, and here's a vent. So this triangle symbol is common for venting. So if we press this button, there on the top valve, then we'll have supply pressure, which is commonly given the symbol of a circle with a dot, and fluid will flow in that direction as indicated in the valve diagram, and this goes to the cylinder. Okay, so this just shows that if we were to press the button on this valve here, then our pressure supply would be connected to the cylinder, and so the cylinder would extend. And then the other valve, this other 2-2 valve, is the same kind of valve. Okay, so that's the, oh, and here's the symbol for vent. Okay, so that's the configuration that the system would be in if you press this button. So that would make the cylinder extend, because this chamber would be connected to supply pressure. So you could label this the up button. And then, now what if we press the other button? So we release the button on the up valve. So that means that the ports are in line with the box on the right. So supply pressure is cut off. And then we press the button on the other valve. So we press that button, and so that makes the ports in line with this box on the left. And that means that this bottom chamber of the cylinder is connected to, or is vented to the atmosphere. So if we press this button, this chamber would be vented to the atmosphere and gravity would drive the cylinder down, so we can label this the down button. So how would you label the push buttons in the system? This would be up and this would be down. If we press this button, then the ports are in line with this position or this box. If we press this button, then the ports are in line with this box, and so in that case, this chamber will be vented. The last slide in this video shows a pilot-operated valve. This dashed line is a symbol for a different actuation type on a valve. And in this valve here, we're using pneumatic pressure to switch the positions of the valve. So whenever this line is connected to supply pressure, this valve would move to the right. Whenever this line is vented, then the spring would return this valve to its normal position, and will be in this box shown here.